All right, would you now please tell me which of the following could be graphs of functions? Okay, I have there four plots. You can see the upper two. I have um, some kind of sideways mountain, however you want to describe that. And then for the upper right one, I have a circle. And then the lower ones, I have some kind of curve there. And then for the bottom right, I have something composed of three horizontal line segments. All right, pause the video and think about those now, please. All right, so answers. The only plots that can be graphs of functions are the bottom two. Okay, discussion. The principle here is the same inputs must always give the same outputs when we are talking about functions. Okay, graphically, in order to force the same input to give the same output for every function, that means no vertical line can intersect the graph in more than one point. Okay, this test is for a valid function is often called the vertical line test. Okay, in other words, every x value has to give the same y value, only one y value. All right, so you can't have an x value that has multiple y values. All right, that's another way of saying it. So make sure you understand that. All right, next topic. Would you please find the domains and ranges of the following functions? I have f of x equals 7 minus x. Then I have g of x is equal to 4 divided by the absolute value of x minus 5. And then h of z is equal to the square root of z. So pause the video and try those now, please. All right, so what's going on here? Answers. The domain of the first function is all values of x. The range of the first function is all values of y. It's common to refer to the domain in terms of the variable x unless the function is using a different variable. And then it's common to refer to the range in terms of the variable y. Okay? For the second function, the domain is all values except for 5. All right? The range is all values greater than 0. And then for the last function, the domain is all values greater than or equal to 0. And the range is all values greater than or equal to 0 as well. All right, discussion. Domains are the sets of all possible input values of functions. Ranges are the sets of all possible output values of functions. All right, if that's not clear, let me give you a couple of other examples that hopefully will help you understand limitations on functions. All right, let's pretend we had a function that corresponded to a date. All right, so maybe we had a month number, the month number function, the day number function. All right, the day of the week function. Okay, for example, is it possible for the day of the week to be, let's say, 8 or 9? All right, no, of course not, because the day of the week, the number of the day of the week is limited. All right, it only goes from 1 to 7. All right, what about the month number? Okay, is the month number can only go from 1 to 12. All right, so you see how there's limitations. All right, the day of the month can only be greater than or equal to 1 or less than or equal to 31. Okay, distances, there's no such thing as a negative distance. If you are dividing somewhere in your expression, you can't have values in your domain that'll cause a division by 0. All right. If you have a square root, or a cube root or something. You can't well, so let me focus on square root, because you could have a cube root of a negative number, but you can't have the square root of a negative number. And then ranges, let's say that your function expression was the absolute value of something, okay? Then there's no way that you could have negative numbers in your range, because the absolute value will always be 0 or positive. All right, so you see how that works? So those are some examples of things that will cause limitations. Okay, graphically, domains, looking at a function plot, domains are all the possible x values, and the ranges are all the possible y values, or all the possible heights for a given function plot. Okay? Now, would you please describe how the graphs of the following functions are related? I have, for the first function, x squared plus 1, that's f of x. For the second function, g of x is equal to x squared plus 3. For the third function, h of x is equal to the binomial x minus 3 squared plus 1. And then for the last function, I have the binomial 2x plus 6, that quantity squared, then I add 1 and take that whole new quantity, multiply it by 3, take that whole new quantity and add 7 to it. All right, so the first one, I'll just tell you, f of x, that plot is a parabola. All right, so I want you to tell me how, and I'll just go ahead and tell you that they're all parabolas. All right, tell me how the parabola of the second, third, and fourth functions are related in the xy plane to the parabola of f of x. All right, so pause the video and try that now, please. All right, answers and discussion. The g of x parabola is like the f of x parabola as it's like as if I took the f of x parabola and moved it up 2 units. Okay, the h of x parabola is as if I took the f of x parabola and shifted it to the right 3 units. Okay, and then the m of x parabola, in order to get that from the f of x parabola, I've got to do multiple shifts and stretches. All right. Function transformations. Okay, if your new function is equal to the old function plus or minus a constant, then the new function plot will be the old function plot shifted up or down. All right. If I add a constant to a function, a positive constant, that will move the old plot up. If I subtract the positive constant, that will move the old plot down. Okay, so adding a positive constant moves it up, subtracting a positive constant moves it down. Okay, if the new function is the old function where you do the modification where you replace x with x plus or minus a number, then the new plot will be shifted horizontally compared to the old plot. Okay, if the new function is the old function where x is replaced by x minus a positive constant, then the new plot will be the old plot shifted right. Okay, and if the new function is equivalent to taking x in the old function and replacing it by a constant times x, third bullet now, then the new plot will be the old plot where it's you stretch it or shrink it horizontally. All right, and then fourth bullet, if the new function is a constant times the old function, then the new plot will be the old plot stretched or shrunk vertically. Okay, please try to commit these to memory. All right, now I understand that you might be concerned that you're going to mix these up and you're going to maybe get the direction backwards. Okay, I have a high value technique for you. Okay, whatever you think is going on, check your answer by plotting a few points. Okay, you don't have to plot every point of the function of each of the two functions to see what's going on. If you plot just maybe 2 or 3 points of each function, that should be enough to give you to confirm whether your new function is shifted up or down or left or right or shift or stretched. Okay, you see what I mean? So again, I'm a big fan of these easy ideas that give you lots of benefit. Okay.